Alright guys, welcome back. It's a fabulous Tuesday. No one's wearing their tutus on Tutu Tuesday, I see. I printed out this constrained optimization example that I sent to an email. This is clearly, or actually more clear than what I wrote on the board. I've got a lot of these. Just pass them back. And you're going to be doing more math in this week. Like the gradient, the slope of math that you're doing this week will be the steepest of the entire semester. So don't freak out just yet. Or don't, well, if you do freak out, then this is going to be your biggest freak out. Okay? Once you get a hold of constrained optimization, you've pretty much gotten all that you'll ever need to know from the math of economics. That doesn't mean that someone won't try and teach you more math in economics. It just means that's all you need to know. Are there any open questions about anything? Yeah?
When will you post the YouTube link to the other lectures?
I am doing what I can. I have like massive technological stupidity. So we just figured out that this 2-hour video thing only lasts for an hour before it decides to shut itself off. So figuring that out, anyway, we'll get there.
Okay.
The MP3, that's on logistical stuff. Someone had a problem downloading the MP3.
Yeah, that was me. That's
why
I was asking for
it should, I just went and looked in the last 2 lectures and it seemed okay. So if you have a problem with an MP3, send me an email and I'll send you a direct link.
Okay.
Okay? Yeah.
Are homework assignments going to be posted to VSpace?
Yes. The homework assignments will be handed out on Thursday and they'll also be posted on VSpace for those people who lose things quickly. Okay? And they'll be due a week from Thursday. All right? And that's going to be a bunch of constrained optimization problems. We went over them yesterday. They're very good. So you guys will have fun with that. Homework should be neat. I think that's all I'm going to say. I'm not going to say typed or anything like that. Yeah?
So what are you doing with the walkout? Since that's
The what out?
the walkout that they're doing?
Who's walking out? Am I?
I was asking if you were because a lot of fact
Whatever. Is this like a union thing?
There's a UC-wide workout on the 24th against budget cuts.
we could be next Thursday when
I don't give a shit. I'm going to take it. Any other questions?
Yes.
I'm going to lose my job in a year anyway. I don't care. Okay. So we did the homework. If anybody is interested, yeah.
Did you just say homework? When will we get it?
You'll get it on Thursday, or we do it on Thursday after that. That's all right. Keyword: penis. Oh, I got it. Okay. If anybody wants a job transcribing these lectures from either the MP3 or the video, send me an email. If you don't know my email, it's stevezetland@gmail.com. It looks like at a rate of about $12 an hour, you're going to get like $30 a lecture. So if you want to make about $1,000 this semester, send me an email. And then if I get emails, it will have transcription. And then they can translate it into Hebrew and all kinds of cool stuff. Any other questions? Open questions?
The syllabus that books will do the 18, but on these bases,
Finish the books. What does it say here now? I've had problems with synchronizing my syllabus with the calendar, and it's me that's the problem, but finish the books, September 18th. Is that this week? Yeah, by the end of the week. It's a rough deadline, okay? It's not like there's going to be an exam on this book, but I just want to give you an idea that you should be finished by now. So, it says 18th on the syllabus and 15th on the calendar. I'll fix the calendar. Just finish the books this week. Is anybody having issues with that? Hopefully not. Did people like the books? Did you like the books? Okay. Didn't like the books? Some parts were interesting. You know, what are you going to do with 300 examples? Does anybody else need this constrained optimization? No? Okay. Yeah, the economics in one lesson could maybe be one chapter, but whatever.
Yeah,
It was free. It was pretty.
in one sentence for the first 2 pages. Why am I?
Well, you got it. How much did you pay for the book? Right? Marginal cost, marginal benefit. It was not very much. I hope. All right. Any other stuff on the books? Questions on that? Optimization. Great. That's good. That takes care of logistics. Any other questions? Anything like that? Yeah.
But for the blog, we just email you.
Yeah. Plain text. Links. Whole thing. By the 1st. For the 2nd. Okay. Huh?
Do we comment on any of them? Or?
So here's the thing. This is going to be a bit of a scrum, I think. So I'm going to be posting about 2 or 3 of your blog posts every day on my blog. It's going to be like randomly showing up in order. you don't have to do anything. You can say my job is done. But I really encourage you to read each other's posts and comment on them. And most importantly, point out the weaknesses. Right? There's 1,000 people that read my blog already, so they will be commenting. And I want you guys to learn from it. This is, in a sense, why the workload might seem to be low. We're only having 3 homeworks, only 1 midterm. Because I want you to put more time into this writing, into learning in the dialogue, in what's going on with just the blog, but also with the rest of the world. Does that kind of answer your question? It's not obligatory. It's just if you want to learn, right? If you don't want to learn, I don't know why you're in the university. Although some people just want to get a higher salary. Let's see here. I'm really being snarky today. So I wanted to finish up some old business and then get to the new stuff. So just as a point of just as a point of interest, remember that markets don't solve. Did I do this Venn diagram already? Let's call this markets. No markets. Missing markets. So, I don't know exactly why it's I think the idea of the overlap between these things is that somehow some goods can move from a missing market scenario into a market scenario. This is the idea of a pollution tax, for example. A missing market, let's go to the market. The idea of a market is beer or chips or whatever, you pay a price, you get the good. And when you buy the good, you pay the full cost of producing that good. Okay? So when you go to the farmer's market and you buy a tomato, you pay the full cost of the tomato. It's the labor, it's the fertilizer, it's the land rent, it's the water, it's the transportation. All of those things go into that cost of that tomato, and you pay the price of the tomato. So your consumption of the tomato is appropriate from a social point of view, a social welfare point of view. All right? Now, if you start to think, oh, what about agricultural runoff or pollution from machines or fertilizer production? Fertilizer is produced with what? Does anybody know? One of the big energy input to make fertilizer. What?
Oil.
Loud, very loud. Petroleum. Not petroleum exactly, natural gas, right? But energy. So the old stuff was, the old fertilizer is cow shit, then it's bat shit, and then they went to artificially produced fertilizer. That's why it uses a lot of, and it uses, that's huge in the argument about ethanol, for example. The biggest part of the ethanol footprint is actually the fertilizer that goes in to produce it, that goes on the soil to produce the corn. So there's energy, it takes energy to make energy. My point is that if all of the prices are appropriate on the input side, and then you purchase the tomato at the market, then you are buying the correct amount of tomatoes for the correct price. But what if there are things that are not, there are costs that are not included in the price of that tomato? The price of pollution, right? Maybe there's slave labor involved, something like that. If in that case, we have what's called a missing market in the sense that the price is wrong. Usually the price is going to be too low. The price can potentially be too high. For example, if the University of California says that we're going to put textbooks on sale for 50% off today, but the queue to get in the store is 600 students long, right? The price you're paying is not just the cash price, but it's also the price of your time, all right? So missing market problems are problems where the price that you pay is not including the total cost of that good, and from a social basis, and potentially for your individual basis. Yeah.
So does that mean that we can move the tomato into the missing market?
Well, the tomato is supposed to be in the market right now, but can we move? We might want to move, for example, driving around, which produces pollution, from a missing market, which is that we have a missing market for pollution. We want to move that into the market for pollution by having a pollution tax, right? A gasoline tax, or a pollution permit, which is supposed to be the equivalent, but may not be sufficient. Okay? But then there's this thing called no markets, and if you remember that the first day in class, I said, well, we've got man plus a woman plus a man. Is it equal to love, right? This, there's not necessarily, money can't buy you love. There isn't necessarily a market for a lot of things that we value. And so economics can't necessarily colonize this part of our life right now. But there are times when markets just won't work. That's the idea of a no market. And it's just, and the idea is that you want this to be a complete Venn diagram of the world. Now, if you go from no markets, can money buy you love? Well, no market into a market. What would that be for? It's literally for sex. What's that called? Right. Okay. And maybe prostitution, when it's illegal, it's a missing market, right? Because you want to have it, but it's highly regulated to the point of being illegal, and so you have all kinds of crime. So you can. What I'm saying is that you can move between these circles, and if you're in one circle, you want to see, should you be in the other, or could you be in the other? What's the cost of going back and forth? A lot of economists say we can fix most of our problems by just putting a market on it, and that can be true. It can also be false. Yeah.
Can you ever be in between markets?
What's an in-between market? Or what are you thinking? Are you just like hypothetical?
No, I'm just looking at the Venn diagram and I don't really understand the spaces.
Here's the space. I guess let's just call this one here sex. Okay? Because sex can either be in a market for prostitution in Nevada or in the Netherlands. It could be a missing market because it's black market in Oakland or whatever. Or there's no market, which is like down at the pub. Okay? Where you have to be much more persuasive. Okay. Other questions about this? I'm doing what I can. Yeah.
I guess I was just confused. Like, how can you be in a market and no market at the same time?
No, I'm saying the good can. It's not at the same time, but the same good might, in some places, be in the market and not be in the market, in a different place, right? So the sex example, you might have sex that is in the market in Amsterdam, but is not in the market in whatever, like I said, Oakland. Okay, it's the same good, but it's just a spatial problem, or it could be a temporal problem. It's a different place. So we're not trying to be quantum. It's not quantum economics we're doing here. Yeah.
Well, I guess if we're considering externalities and stuff, then is anything in a market?
Externality would tend to fall into the missing market.
Well, right. So then, would anything really fall into it?
Oh, if the world is full of externalities, then maybe there isn't, right? So if you have, okay, so say that I've got a pen and you got a pen, right? And they've already been produced. All the cost has been taken care of, right? And we swap pens. That, in a sense, is a market transaction. There's no externalities produced because the production of the pen has already occurred. So, in a sense, used goods can be they can be quite good as far as market costs. The price has been paid or avoided. Other questions about this? Yeah.
If you swap pens, aren't you in the no market section?
No, it's just barter, but it's market is a transaction, a mutually agreed transaction. Okay, no market means you can't get it at all, right? The Beatles song about love. Any other questions on this? Okay, that was meant to be an overview that I should have said a long time ago. Let's go over elasticity again, because when people come to office hours and they say, I don't get it, I say, oops, I better do a better job next time. So I'm going to use this screen here, actually. It's bored. I'm going to put up that diagram that we had for the linear demand curve and talk about how elasticity changes. Just for a clarification, Today, the labeling the axes is going to be very important today, so start paying attention to that. You've been lazy. So elasticity at point A for this good is what? More elastic or less elastic? What's the formula for elasticity? Change in quantity, change in price, quantity, right? What's in an A? What's the elasticity? Price elasticity is what? Higher is, give me a, is it higher meaning 0 or high meaning infinity? 1. That's in the middle. Anyone? Huh? At point A. Price elasticity is infinity, but not just infinity, it's minus infinity, right? Because this is price elasticity. Over at point C, what is it? This should be easy now. 0, okay? And so basically what we're doing here, and at point B was 1, as was told to us in the second row here. So what we have is this range here of elasticities And you're going to have that as you move along this demand curve. Okay? And it's weird because we think, oh, it's just a line. It should be quite simple. But the problem is the Q, right? As Q goes to 0, it's in the denominator. As Q goes to 0, elasticity goes to infinity. Okay? And what's the intuition behind that?
Why is it negative?
Oh, because we're talking about price elasticity, right? What's the law of demand say?
Demand decreases, the price goes up.
Okay, so that's an inverse relationship, right? So as the price goes up, you demand less. That's why it's minus infinity. Okay? That's a good question. And also, let's take a pet peeve. A lot of people, professors or whatever, the teachers will say elasticity is for bananas is 0.5, but it's really minus 0.5. And then they get into this elaborate explanation about why we always use absolute values or whatever. But really, just to keep it straight, it's negative. And if the price elasticity is positive, that means if the price goes up, you buy more. And that kind of works with like wrappers and bling, but it doesn't work with reality. Okay? Oh my God, $1 million necklace. So that's the idea is that there's ranges of elasticity, and the range is you're going to be moving from 0 to minus infinity. Is that clear enough? Is that clearer than what you guys saw last time? There will be a question on this, right? So you're paying attention on the exam and the points and the grade and all that stuff. So, and just as a point of notation, because Faye is trying to be clear, and I'm going to help him be clear, is that the elasticity in this range here is in the set of minus infinity to 1. The elasticity in this range here is in the set of minus 1 to 0. Now, you will see that I'm using a combination of curved brackets, parentheses, and square brackets, right? This is a mathematical notation for sets, and I'm putting it up here because I want you to. It's going to come up in your homework, or it might, or it might not, but it will come up in the future. Basically, if it's around parentheses, it means it doesn't include the number here. It doesn't include minus infinity, because you can never include infinity. Infinity is too big, right? And it also doesn't include minus 1. Why doesn't it include minus 1 in terms of this elastic range? Why doesn't it include minus 1 in that elastic range?
Because minus 1 would make a unit elastic?
Perfect answer, okay? Because minus 1 is right here. So in the elastic range, it's everything from minus 1 to minus infinity. In the inelastic range, that minus 1 is there. Unit elastic, it's minus 1, and it has a square bracket on 0, which means that you include 0. 0 is perfectly inelastic. That means there is absolutely, when the price changes, how much does your demand change?
Same exact amount.
It's same, it doesn't change, right? Same exact amount. Your demand is the same. Okay? You're inelastic. Okay? Is that useful? Okay? That's elasticity. And also, let me point out, there's some question about if you're at point D here, it kind of makes sense that as the price drops, you're going to demand a lot more because you have a very elastic response, right? But if the price goes up, do you demand a lot less, your demand drops by a lot? It's kind of a strange idea to think about the price goes up and your demand drops by a lot. It drops. I mean, the whole point, though, is that you have strong reactions to price changes in this range. Okay? That's what I want you guys to understand. You have strong reactions to price changes in this range because you're very sensitive in this range, right? And you're going to pay a lot of attention to price, but you're not going to, it's just, that's what I'm trying to say. You can have a strong reaction to price. It's kind of counterintuitive to say, it makes sense that if the price drops, you're going to demand a lot more because you've been pushed to the wall of almost no quantity, right? If the price drops, you're going to demand, a lot more. That makes sense. But if the price goes up, you're going to demand a lot less. That doesn't really make very much sense because you're like, wait a second, I thought I'm really sensitive right now. but you're going to have a strong reaction. That's what I'm trying to say. You're very sensitive. And it's I can't even get my head around the idea right now, but just keep in mind that as you move in this direction, you're having stronger and stronger. Oh, that's it. You're having a stronger and stronger utility response in terms of how much goods you have, right? So your utility is being impacted very strongly because there's less and less of the good around. I'm not going to ask you to write an essay on that, but I want you to think about that. Mostly it's the idea of like you're in the desert, you have 1 gallon of water, you have half a gallon of water. It's like you're really starting to pay attention to water the less you have. Okay? That's the end of inverse demand for the time being. Elasticity. Anything else? Any questions on that? Okay. And on a similar note, inverse demand was very confusing for some people, so I'm going to step back for a second and go over that. This is the reason I want you guys to have really strong grasp of the principles. That's why I'm going over this and beating on some points that might seem a little bit weird or pedantic. But if you're doing economics, and you will almost all, who's going to take another class after this one, assuming I do my job right, okay? So I want you to have a strong intuition and a methodological abilities so that when you see more and more economics as time goes by, you're not confused, you're actually learning it. So here's the thing. We think that the quantity demanded of an individual, as opposed to aggregate quantity demanded, which is big Q, this will come back, is a function of price. Okay? That's you go to the store. You look at the price of a CD or a quart of milk or whatever. You pay attention to what the price is. When we graph it, now let's just take an example here. Let's just say quantity demanded of good 1 is equal to 1 minus P. Okay? Now if I graph, and I say P is the dependent or the independent variable here. Independent. You go to the store, you look at the price, you decide, right? So, our notation is usually like this. Okay? When price is 0, the quantity demand is what? 1. Right? If the price is 1, the quantity demanded is 0. Okay. That's not very hard. And you think, oh, that makes all kinds of sense. But remember, in economics, we're doing the inverse. We're inverting that. And for this example, it's conveniently symmetric. So the math is, this is Q equals 1 minus P, and this is P equals 1 minus Q. Now so here's what I'm getting at. Why do we use this inverse demand? Okay? The simple answer is that it's very convenient to keep Q on the x-axis. Not earth-shattering. Nope. And here's my helpful diagram. Here's Q. Here's utility, right? Utility is going to start at 0 and it's going to rise at an increasing or decreasing rate. Decreasing rate, right? Nice utility function. Marginal utility. Guess what? We put Q down here. That's why. That's why we invert demand. Okay, Q is on the x-axis. Oh, I can look it up. Okay, Q, Q. This is why we use inverse demand on the graphs. Okay? Marginal utility, U prime, is going to be, in general, is going to be increasing or decreasing? Decreasing, right? Basically, let's just say it like that. I'm not even going to bother to make the calculus perfect, right? So the point is that we put Q on here so we can just kind of stack these up, right? And surprisingly, or not surprisingly, our marginal utility, this is like a demand curve, right? Our marginal utility and the demand curve are, with a little bit of transformation because of prices, the same shape, right? That's why we use the inverse demand curve. Now, why does this matter in terms of, why don't you just take it as given? Because I want you to avoid the confusion that will happen in the following circumstance. Let's change this thing Qi equals 2 minus 1/2 P. Not a big change. But then, if we draw that, putting P here and Q here, when price is 0, quantity is what? 2. And when is quantity 0?
4.
4, right? So if we invert that, then we're going to have the opposite intercepts, right? This is the demand curve that you'll be seeing in front of you, but this is actually what's going on. So what's going on in your head is, oh, the price is changing, my quantity demand is changing, and then I say, graph it. And then a huge percent, and I've actually done experiments with undergraduate students, a huge percentage of students try and do this and they screw up, right? Because I tell them, do an inverse demand curve, and they draw this. They draw the wrong one. Because they have to flip it over. If you flip it over, you get P is equal to, just so I don't look like an idiot, 4 minus 2Q. I say this is the demand function, or I say this is the demand function, graph it. They draw the wrong graph. They, students, you guys, your peers. But this is what you should be drawing, the inverse demand. Okay? It matters when you're adding up two people. You get Mr. Q1 and Q2, and let's say that's 3 minus 1/4 P. You want to start aggregating this stuff up. It gets more and more hard to put on the graph or to add together. That's what I'm trying to point out. There are calculation mistakes that will happen when you're trying to use inverse demand. Is that a little bit more in the right direction in terms of this makes sense or this is useful? Okay? It's the conventional wisdom and it's the conventional presentation in economics that we use this. And this is what you're going to be using, but I want you to understand that there's that little trick called inverting going on, and you will not make mistakes in terms of presenting the material that way. But it's also kind of useful to think about why we, or how all these graphs fit together. Any questions on inverse demand? No? Okay. Off we go. Deadweight loss. Yay. Okay, so what's deadweight loss? What does that mean? What does it mean? Loss of efficiency, right? So let's start with some. This is, as I said, this is kind of like going back over some stuff. We're on the full market right now, so we have aggregate quantity. We've got our supply curve and our demand curve, and this is our equilibrium point. P star, Q star. Let's just do some labels here. A, B, C, D. What's the social welfare in this diagram? A? A and B, right? Okay. So, let's say that we impose a tax. It's going to drive a wedge between the supply side and the demand side, right? The tax is going to give us a new QT. This is the tax revenue. And the deadweight loss is where? The triangle, right? Here. This is a loss in social welfare, right? We in a sense, reduced efficiency. We've lost some goodness from exchange because the tax makes the price that consumers pay different from the price that producers receive. Okay? Deadweight loss, that's what we call it. Now, just to extend deadweight loss, to keep the political economy theme of this class intact, is there any deadweight loss connected to collecting taxes? Who here does their taxes? Does it take you more than 0 minutes? Yes, right? That's a deadweight loss. That's your time, right? What you really want is just for the money. I mean, you don't want to pay the taxes at all, but if it was going to happen, just disappear the money. I don't want to deal with it, right? You don't necessarily notice it when you pay sales tax. You just go to the store, you buy your stuff, the tax is added, off you go, right? Or you go to a meal, and oh my God, I got to leave a tip, right? And then you're there with 4, 6 people, and they all want to use their own credit cards and leave different tips, right? That's deadweight loss, kind of another kind of deadweight loss that is not in this triangle. That's connected to this tax. Okay? Often it's smaller than the size of the tax, but what it does is it reduces this tax. Because what is this tax considered? What is this tax considered to be in terms of who wins and who loses? Why is it not a loss, usually, under typical economics? What?
Well, it goes to the government.
It goes to the government. It's a transfer, right? It's just like supposed to be a frictionless transfer. But if there's friction, then this nice little net transfer gets smaller and smaller and smaller the greater the friction. If you send lobbyists to Washington, D.C. to lobby for a tax on your behalf, because you're part of the healthcare industry or you're part of the agricultural lobby or whatever, those are more deadweight losses. Okay? I'm not sure, but I wouldn't be surprised in some circumstances where the if I change the price of when you're talking about the AC, or Damien talked about the AC Transit example, the bus is empty, right? And the idea is like if the bus is empty, what should the price of the bus be? 0 until congestion shows up, right? But what if someone says, let's just charge a penny, right? There's this massive reduction in the number of people riding because it's like, I don't have a penny. It's a pain in the butt to have a penny in your pocket, right? So a tax of 1 cent can actually produce more deadweight loss than revenue. That's the idea about deadweight loss connected to taxes. Subsidies, what would a subsidy look like? Anyone? Louder? No. Does the subsidy increase or decrease consumption?
It increases.
Increases. So it's going to be over here somewhere, right? Basically, we just say a subsidy makes that the price that the producer receives is higher than the producer pays, right? This is basically, so all of this box here now is coming from the government, right? Usually it's coming from the taxpayers, because the government is just an accounting device that passes it along. So a subsidy to car manufacturers to sell clunkers of $1,000 a car is coming out of all of our pockets, and it's going to the people that buy cars, right? And it's being divided, in fact, among the people who buy cars and the people who sell cars. But that is this entire box here. What's the deadweight loss associated with the subsidy? Anyone? A letter. Pick a letter. C? No. D, right? It's because the value, at this point, the value of this good is much less than the cost of production. It is inefficient. It is a deadweight loss. Okay? That's essentially, subsidies and taxes are essentially mirror images of each other. Okay? Keep that in mind. For conventional wisdom, keep in mind the size of those triangles. For political economy, keep in mind how those triangles get made, right? How the process of setting the tax or setting the subsidy, which is awfully important. It turns out that you can go to Washington, D.C. and spend $1 and make $200 by bribing a congressman. It's a pretty cool business, you know. Now you know why there's 40,000 lobbyists in Washington, D.C. Pretty sad for all of us, though. All right, so any other questions on deadweight loss just now? Yeah.
Yeah, I don't get the second letters, and also I don't.
You don't get the idea of the letters?
But yeah, I don't know why you accept it.
I just said which one is the deadweight loss from a subsidy.
Oh, okay.
Okay, D is the deadweight loss from a subsidy. It's just almost random letter placement.
And I also was wondering, like, on all those examples, what does that have to do with like loss of efficiency? I don't think I.
Loss of efficiency. So, say that this guy can produce this bottle in 1 hour, right? And you can do it in 2 hours. And for some reason, you are the only person I can hire. I just wasted an hour of everybody's time having you do it. You're less efficient than he is. That's the inefficiency, right? It's like a tariff will protect American sugar producers from the Brazilian sugar producers. So Americans, if you didn't know this already, we pay like double the world price of sugar, producing sugar that we shouldn't be producing. Okay, because it's essentially a subsidy to U.S. sugar producers.
Well, like, why would it, like, a tax cause deadweight?
A tax will cause deadweight loss in two respects. One is it'll restrict the amount of trade going on, so quantity is falling. That's the triangle. And a tax will have a deadweight loss because of the lobbying about who gets to set the tax on what, where. Okay? Good question. Yeah.
What would be the price charged for the subsidy on that graph?
The price charge is going to be the lower number here. Right? The higher number is the price received by the producer. The difference is the amount of subsidy. Yeah.
So would a tax be analogous to a price ceiling?
Analogous to a price ceiling. In the sense of,
that it's
yeah, in the sense of deadweight losses, let's do that one. So a price ceiling says that even though this is P star, we can only charge this much. Okay? Price over bar. The quantity in the market is here, and the loss, the deadweight loss is here, or is it? So a price ceiling, so the price ceiling, you've got to somehow, a tax is worse, a price ceiling is worse than a tax, because a tax creates this box here, which is a transfer between, from the people making the transaction to the government, which goes to somebody, right? That's actually just a transfer. But if you have a price ceiling, let's see here. You have to somehow, the consumer is paying this, and the producer, consumer is paying that. Well, sorry, this is the demand here at that price. The demand is greater than supply because the price is too low, right? So somehow you've got to raise the price so that the demand actually equals the supply at that price ceiling. That price is usually raised through queuing, right, or waiting, right? This is the New York rent control market, right? Some people in New York, they lived in the same place for 15 years, or they haven't even lived in New York, but they have the same place, right? So the price is raised in some way that is not a cash way.
Price is raised?
Diagramming all the little angles, triangles, stuff like that is, I should probably do it, but I'm not doing it right now. So it's not the same. The losses are worse in the price ceiling. That's the.
But it still creates that loss.
It creates that loss plus more. Price ceiling. Yeah.
So do all taxes create deadweight loss? Or
In theory, yes.
so
When they would not create deadweight loss is when?
there's no transaction cost at all?
Well, no. The transaction cost is going to be there. This board is completely useless. If I write here, do you guys see this? Okay. Okay. I'm just like hating. So when would a tax not create a deadweight loss?
Correcting for an externality.
Okay, that's not exactly right, but it would.
No, but
I think that's okay. Let's put that aside and say yes, but not what I'm thinking about. So, what about this scenario? Or no, I want perfectly elastic demand. Perfectly inelastic demand. So we do supply, we have demand. Right, here's the price, and now I just raise the tax. There's no deadweight loss because the amount consumed is identical.
so are there economists who would say that taxes, because this almost nothing has this demand?
Well, this supposedly is the case with what? Cigarettes, right? Let's just tax the smokers.
Okay.
$7 a pack. You know, in Europe it's expensive for cigarettes.
But then, I mean, it's basically saying that taxes are always inefficient, except for some very rare cases when people are addicted to something.
Taxes always produce losses. Whether or not they're efficient is a different question.
Okay, so deadweight loss and efficiency are not necessarily connected.
They are.
I mean, I thought something is inefficient if there's
No,
a
'cause-
deadweight loss, right? No.
Well, the deadweight loss is about social welfare, surplus, right? Efficiency, you know, whether or not it's efficient or not is, like in the case of the pollution tax, is a different question. It's meant to offset it. If you have just a tax on cigarettes, it's a subsidy would be inefficient because production goes beyond where it would be. A tax reduces social welfare. Is that the same as inefficient? Not necessarily producing inefficiency. So it's not, it doesn't map one to one. It's not identical, right? So if you need to know what's going on with taxes and subsidies, there's always a welfare impact, always, and there may be an efficiency impact. How's that?
Okay.
As a clarification. At least it seems to be a clarification. I don't know. Other questions about this? Should do a whole lecture on deadweight
And
loss.
so, based on my understanding, then the more elastic it is, the higher the deadweight loss.
Yes, right? The more elastic. Let's do this. You know, we got this, and here's our tax compared to over there, right? So the triangle will grow in size the more elastic things are, because the more elastic, the larger the response. That's elasticity. Okay? So yeah, but you know, the number of goods in the world that are perfectly inelastic is very small. Yeah.
Can you give an example of what deadweight loss looks like for subsidies?
That's what I just did in the triangle
Well,
over
I
here.
know,
That was
but
D.
I guess I'm still feeling clear, like why haven't we had subsidies?
Because the American car producer, or the American sugar producer that's producing sugar should not be producing sugar. They should be doing something else, right? Producing alligators or something like that. So in Florida, they do it in Florida, and actually the Katrina, a lot of the Katrina damage was, some of the Katrina damage was exacerbated by the sugar production in Louisiana. They changed the bayou into fields, into agricultural areas, and then the bayou didn't absorb the wave, storm wave. So bang, you get a bigger impact. So that's like a crazy example of deadweight, of a inefficiency from that, or a loss, social welfare loss. Good topic. Let's turn off the tape and turn on the tape for a second. Oh my God, talking about things turning off. So say that I get utility from is a function of beer and chips. And I'm going to put chips on this axis and beer on this axis. Both of them are normal goods. If I have more beer, am I happier or sadder?
Happier.
Happier. Forget satiation for a second, right? If I have more chips, am I happier or sadder? Okay, now, here's the question though. There's a trade-off between these two. So I'm going to show you, if I say that beer and chips are perfect substitutes, what does that mean?
They each bring you the same amount of happiness?
In a sense, not exactly. If I take away 1 unit of beer, then I have to add or subtract chips. Add. Let's see, we know about beer and chips, right? So if I'm here and I take away some beer, then I have to add some chips in order to remain indifferent. Okay? Now, I take away another beer. Do I add more, less, or the same amount of chips?
The same amount.
The same amount. They are perfect substitutes. Okay? And what does that mean by the same amount? That means that the trade-off between beer and chips is constant. Right? The slope of that line is the same all the way along there. Now I'm going to call this utility 1, because my utility on this indifference curve is the same everywhere on that indifference curve. You are indifferent. That's the meaning. Indifference curve, you're indifferent. You don't care. I could be here, I don't care, I'm just as happy. Yeah.
If you have to give me 2 bags of chips for every 1 bottle of beer, which would change the slope, but still, is it still a perfect substitute?
As long as the slope is the same slope, it's okay. 2 for
Okay.
1, 2 for 1, 2 for 1, that's fine.
Okay.
14 for 1, 14 for 1 is fine.
Okay.
Right? Now, am I happier or sad? Where am I happier? A or B? B. I'm happier because more is better. This is my utility is increasing. Okay? So the utility on anywhere on Indifference Curve 2, my utility is the same, less, or more than on Utility Curve 1, Indifference Curve 1. More. You have more utility on 2 because you have more of both, right? Here's how much beer and chips I have. It's like, wow, look, more chips, right? Or more beer. I'm happier. Those are perfect substitutes. But in general, indifference curves, in general, if you're drawing a trade-off between 2 goods, can I draw a straight line? No, thank you. True. Okay, so in general, your utility is going up as you have more, right? This is one of the basic assumptions of economics. Remember I talked about satiation the other day? If your utility is going up and then your utility is going down, essentially as you go out here, that's like, I had too much beer, I threw up, right? That's satiation. But and what we're going to assume almost all the time is that you're not satiated. So what happens if I need to have, for every beer I have to have a bag of chips. What happens if you give me 2 bags of chips? Huh? So I'm here, and I go here. Am I happier or sadder or indifferent? If I need always to have 1 beer for every bag of chips. Not sadder. You just gave me more. What do I do with a bag of chips? I throw it away. I don't actually care. Right? More chips does not help me. You can give me as many chips as you want. I haven't gotten any more beer. I am not happy. Right? And similarly, if you give me more beer, I still have only 1 bag of chips. I don't care how much beer you give me. I need more chips if you're going to give me more beer. Right? This is actually an indifference curve. Who's the Russian it's named after? Vasily Leontiev. He was actually an agricultural economist, and what he talked about is the idea that you need to have things in a fixed ratio, right? These things are what are called perfect complements. Is my utility higher in U1 or U3? Where is my utility higher? U3, more is better, right? But I need to maintain the ratio between these goods. The way that we write this utility function is utility is the minimum of beer, chips. Okay? If we have a 1-to-1 ratio, which I've basically told you we do, then that means if I have, let's look at these numbers here. I've got 2, 2, 2, 3, 3, 2. The utility is the same for all of these combinations. 2 beers, 2 chips. 2 beers, 3 chips. 3 beers, 2 chips. They're the same utility. Because I'm on this same indifference curve. I need to keep that ratio in 1-to-1. If you give me more beer, you've got to give me more chips. They're complements. They go together. Does that make sense? Does it make sense? What part of it doesn't make sense? I hate the whole idea of economics. Help me out.
More.
Yeah.
So for each of the 2 graphs, they're both indifference curves?
I'm drawing lots of difference in difference curves. These ones are indifference curves for perfect complements. Yeah.
So you're saying that for this ratio is not correct, that they're not going to be happy with any of the following ratios?
They're not going to be more happy. Right? They're going to be just as happy. Right? So if I'm here and you give me more chips, I'm not happier. I'm just as happy as I was. I'm indifferent. You give me more chips? Whatever. I don't care. I might as well throw them away. Give me more beer? Then I'm happier. We have more beer and more chips. Right?
Wait, why is the utility same for all those? Because those different ratios.
No, this is the ratio that you have to maintain. So this utility here is a 1-to-1. This is just extra. I don't even need that. Doesn't even help me. That 3, right? 3 or 42. I don't care how many bags of chips you give me. Unless you give me more beer, I'm not going to be happier. I need to like right hand, left hand, keep them both going. Or here's a really easy example. Left shoes and right shoes. Sorry, I should have just done the easiest one. Left shoes and right shoes. How many, left shoes do you have in your closet without right shoes attached to them? Right? It's like, oh, I lost a shoe. Well, I really love having one shoe. That's what you need. You need to have pairs of the shoes. That's a 1-to-1 ratio. Beer and chips is a little bit. I'm using beer and chips because it's stylized in order to hit all the different indifference curves. Substitutes, complements. Yeah.
But I think when we think that the more is better always holds true, then that doesn't quite make sense, because I could theoretically then trade my bags of chips, like 5 bags of chips for another beer, and I keep one of the leftovers.
You're trading. Okay, now you're in a market. We don't get to do that yet.
Okay.
Okay, but you're right. So I'm going to say it this way. Here's what I'm going to, in order to be really math geeky on you. Utility of 2 and 3 is it's greater than or equal to, right? But in the case of perfect complements, it's only equal to, right? In the case of substitutes, it's greater than, right? So in a sense, the utility of more is like either you're not worse off, you might be better off, but you're not better off if you have perfect complements. Okay, so this is actually the utility of more versus less. You're either going to be better off or the same, and with perfect complements, you're only the same. Does that make a little bit more sense?
I mean, it makes sense in theory. I don't quite believe it in practice, though.
Left shoes and right shoes. How many left shoes do you have without rights?
I don't have. Actually, I have one, because I'd still keep.
You're still waiting for that right shoe to come back.
Well, I would still just keep it around, and I think most people, for example, in a restaurant, if you offer them what goes together, let's say hot dogs and beer,
Right.
and they only like to drink like one beer with one hot dog,
Right.
and you offered for the same price 2 hot dogs and 1 beer, I think most people would still go for it.
That's
even
why
though
we're
they
all
don't
fat.
Right, even though they don't have a use for it, because you just think, well, maybe for later on, or maybe there'll be.
But these are so the perfect complements is an extreme example. Okay, perfect substitutes is another extreme example. Like most people say, you know what? I don't want more chips. I want some beer now, right? So now let's bring that up, because that's a good point. Let's go to the way most of the world works, right? The indifference curves are somewhere in between. So we got okay. So somewhere in between this world and this world, perfect substitutes and perfect complements, what's in between? What are they going to look like? What's the mathematical name for the shape? They're convex. Okay? That's my indifference curve between beer and chips. Or, in fact, mine, most people's. Most people are like, yeah, a little beer, a little more beer, a little more chips, I'm all right, I'm happy with that, right? I don't, you can't give me more beer right now, I need some more chips, right? They're not necessarily perfect substitutes, they're not necessarily perfect complements, they're basically just in between. I don't even know what the word for it is. So do you know the name of the word for in between? Or Diana? They're whatever, the rest of the world, right? This is like 99% of the world. This is left shoes and right shoes. In my world, this is like Coke and Pepsi. He's like, I want Coke. They say, we only have Pepsi. Okay, I'll have Pepsi. Right? That's kind of the Coke and Pepsi. Or a $1 bill versus another dollar bill. Right? It's still $1. That's perfect comp substitute. So, what does this mean here? Is more better in this world? Yes, it's still better. And now there is a trade-off between these goods, but the trade-off is not always the same. And here's the thing. Say that you've got a whole bunch of beer, but not very many chips. if I take away, if I say I'm going to give you another bag of chips, are you willing to give up a lot of beer or a little beer? A lot of beer, right? Let's just do it. Let's say this is 1, and let's say this is 4, whatever, right? Because you've got so much beer, you're like, I got plenty of beer. You got 4 kegs and a bag of chips. It's like, okay, give me one more bag of chips, I'll give you a keg, right? I know. Don't worry, we can't store kegs in this world. So the thing is that you're willing to give up a whole bunch of beer to get one more bag of chips, and you are indifferent at that new point. Okay? So that's the trade-off. And as you go along here, and now you're over here in chip land, and I say, I'll give you another beer. Are you going to give up a lot or a little bit of chips? A lot, right? You're going to do the same thing. Basically, what that means is that if you have a whole bunch of something and not very much of the other thing, you're willing to, the ratio of exchange changes depending on how much you have. Okay? In order to maintain your point on the indifference curve. Obviously, if I go from here to here, I'm happier. Even though I have the same amount of chips, you just gave me beer. I'm as happier, right? I'm on a higher utility curve, a higher indifference curve. Sorry. Okay? That's what indifference curves are. And now, why do indifference curves matter? The handout I gave you is called constrained optimization. Oh, it's called constrained optimization. And what's the constraint when we have constrained optimization? What? Income, money. There was no money on these indifference curves between beer and chips. Right? So, when we just draw an indifference curve, there's no money. And technically what at this point here, there's a marginal rate of substitution, right? There's a substitution between one good and the other. It's called marginal because it's a curve, and we use calculus, and on the margin, it's a small change in one thing and a small change in the other thing. So we change in beer for a change in chips. I think we're going to do this. Chips, beer. Depending on where we are on this thing, is going to be the marginal rate of substitution. Okay? Depending on where we are. And you can depending on where, oh man, I'm getting confused. A certain change at this point, a certain slope at this point, is the calculus part, right? Adjusting for where you are is what makes that marginal rate of substitution the same. Or help me out here. Is it the same? The elasticity is the same along this curve. But this is the elasticity part. This is the marginal rate of substitution part. Right? Maybe?
I think this is a marginal. I think this is a MRT.
This is marginal here.
Yeah.
And this part here is getting into elasticity.
No, I mean this is not a elasticity because this is just a preference, right?
Yeah.
So
no prices.
No prices. So this is not elasticity, but this is a special. This is
the
a
marginal
case
rate of
for the
substitution is
marginal.
changing.
Yes.
Okay. See how precise I am. The marginal rate of substitution, the slope is changing, right? So the amount you'll substitute one for the other is changing. That's what we mean by marginal rate of substitution. And as you go from here to here, they're not the same. Now, if we wanted to find out how much we would consume, if more is better, then we just want more and more and more. The constrained optimization, to get back to what I was trying to say, is how much money do we have, right? So, let's just say the price of beer equals 2, and the price of chips is equal to 3, and say that our budget is equal to 6. If I spend all my money on beer, how much beer can I buy? 3. If I spend all my money on chips, how much can I buy? 2. This is my budget constraint. there's a trade-off, an economic trade-off between these two goods, right? Where I will consume, which is this line is meant to be exactly tangent, exactly just touching, is right here on this point A, right? I will consume A units, or the bundle A, which is based on the price of chips and the price of beer and my budget. If you give me more money, am I going to consume less or more of these two goods? More, right? If you give me more money, is that budget line going to shift out or in? Out. Is it going to be parallel or change the slope? Parallel. The slope is not changing. The price hasn't changed. We just changed this. Let's call this 12, right? So now we're out here. Oh, that's the worst tangent line I've ever done. This is why professors use PowerPoint, so they don't have to worry about drawing badly. So we're going to go from this point to that point. It doesn't necessarily matter what the bundle of goods is at that point. You're just going to consume more, okay? And you're going to be on the highest possible indifference curve. So say that I have, this is an indifference curve here, U1, U2, U3, okay? And say that this is my budget right now. Am I going to be on the indifference curve 1 or indifference curve 2? 2, because 2 is tangent right here. That's as much of the good as I can afford. If I'm at indifference curve 1, I got all this area here that is that I'm not getting. I can consume here, or I can spending all of my money, but I can actually be on a higher indifference curve by also spending all my money by changing the ratio of the goods. Okay? So I can go from here, I'll consume a little bit less chips, a little bit more beer, and I'll be happier. So you're always going to be tangent to that budget constraint. So when we say constrained optimization, that means we're going to be optimizing as much as we can subject to the constraint. And the constraint is price and budget. Okay? The optimization is what's the bundle we're going to consume. It's optimal to consume so that we're right here, so we're a tangent.
So under U1, you have room to choose what you want to do?
You have room to choose, but you just bypass that whole thing and you go to U2.
But could you...
You could either consume...
Could you want U1? Because that way it's like, well, what if I actually... Like, I guess...
You could want U1 if you don't want to maximize how much you consume. But we assume that you want to maximize that. So that's kind of where... So that's that satiation problem. Like, you know what? I've had enough beer and chips. I don't want more. Right? If you're this, you're essentially indifferent between these 2 points with U1. But right here, you prefer C to A or B for sure, because of that's the indifference curve. You're like, and this is a higher. As you go up, you get more utility.
But then, like in theory, could it be like if one day you really want beer, you could use U1 and say, well, look at how much beer I have under my budget.
Well, that would mean that the shape of your indifference curves are changing.
Yeah.
Okay? So instead of being, let me just draw a little version of that. So instead of having this kind of indifference curve, you're having this kind of indifference curve. You're changing your indifference curve. The important thing is that this is today and that's tomorrow. Right? The important thing is economists assume that your indifference curves are the same shape on a given day. Right? This is a consistent set of preferences. It's inconsistent to have indifference curves that cross, because we don't know what the hell is going on. And actually, that's a big point in terms of the math of economics, which I'm going to get to these preferences. Yeah.
This is always assuming an individual wants to maximize, right?
Right. It's constrained optimization. So that if it's unconstrained optimization, it's like I've got too much money, I don't care, I'm done. Then there's no math to do, right? You just they just choose something, and as an economist, you're like, I don't really know what they're doing, but that's what they do. But that's the whole idea. People do hit a satiation point at some point, right? So that's why we assume non-satiation, so we can find that optimal point. And that's what you will be doing on homework, assuming that you're satiated, not satiated. Other questions? Someone else with a hand up? Okay, I'm going to keep pounding on this preferences thing for a little while. Ah, yes. just as a when we draw this set of preferences here, and we're trying to describe the utility function that underlies these preferences, we say that this is utility is equal to minimum of beer, minimum of beer or chips. We have to have those in some kind of fixed ratio. Here we say utility is equal to beer plus chips, right? It could be in some ratio. It could be 2 beer plus 1 chip, okay? But this is the same idea. We have that, that's how we write down that utility function. We have this kind of constant trade-off. In the middle, we need a little bit of each. So we say that utility, I'm just going to say beer to the alpha, chips to the 1 minus alpha. So it's an alpha, if you look at alpha, if you assume alpha is positive, which we do, and it's less than 1, because utility goes like this, right? If it's like this, that's alpha greater than 1. So we don't have this kind of utility function, right? The more I have, the happier I am. We don't do that. That's not happening. That's alpha greater than 1. This is alpha less than 1, okay? So if we say that it's beer to the alpha, chips to the 1 minus alpha, the sum of these exponents is 1, that's a particular kind of utility function, or a particular mathematical function called a Cobb-Douglas, not a Cobb salad, with 1s. This Cobb-Douglas thing is going to hit you over and over and over again for the next 22 million classes. Okay? The generic form of a Cobb-Douglas is something over here. Could be a production function, could be a utility function, and it's going to be x to the alpha, y to the 1 minus alpha. It's just used all the time. It's mathematically convenient. Okay? And we'll get to production technology. It's a strong assumption for production. It's not such a strong assumption for utility functions. And basically, look at this for a second. Think about this for a second. If you have that shape of a utility function, you don't even know what alpha is. But if beer is equal to 0, what's your utility? 0, right? 0 times anything is 0. That's an important point. Chips are equal to 0, your utility is 0, right? So you need to have some of each. But there's going to be so that's why these things actually they just go asymptotic. They never touch the axes, right? These indifference curves. This will go out to 1 beer and 600 million bags of chips, but you never go down to 0 beers. Because in your utility, 0 beers is right here. 0 utility. So this form is going to be used all the time. Essentially means that there's the amount of your utility depends on the amount of beer and the amount of chips you have. You can't have 0 of 1. Yeah. Alpha is just an exponent between 0 and 1. So to use that notation we just had, it's not equal to 0 and it's not equal to 1. It's somewhere in between. Okay? I'm not saying this. That's not it. Okay? Now, just as a quick hint, good, we're doing well. Okay, as a quick hint, my utility is equal to B alpha C1 minus alpha, and I want to do a Lagrangian. Then it's going to be B alpha C1 minus alpha minus that price of beer plus price of chips minus M, right? That's just a generic setup for a Lagrangian using this utility function, right? Now when you take a derivative with respect to B, you're going to have alpha B, alpha minus 1, times C1 minus alpha minus lambda P B. That is a mess. Okay. Now you know it's a mess. So there's in mathematics and economics, we assume you can use what's called just a monotonic transformation. I'm just saying the words monotonic transformation basically because it means that it doesn't change the order of things, right? 2 is always greater than 1. 3 is always greater than 2. So monotonic means things are all moving in the same direction. And you can do an assumption. You can rewrite this without failing the class. You can rewrite this as alpha natural log beta plus 1 minus alpha natural log of beta, chips, beer and chips. Now when you take a derivative of this, I'm writing this down because this is on your homework. And you guys are going to cover this in section. You can take a derivative of this and you get alpha over beta. That's a much simpler alpha over beta plus, well, this is with respect to beer. Oh, sorry, alpha over beer. So alpha over beer. This versus this. This is much simpler to work with. Did I do that right? Okay. I can't do math. So this is much simpler to work with. And this is the hint, right? If you see one of these things, transform it into this, then start taking derivatives, and you'll get chunks like this. It'll be minus lambda price of beer, right? This is much simpler to deal with than this up here.
I think you missed the alpha minus 1 because you take log, you get.
Where am I here?
Oh no, it's fine, it's fine.
Yeah, it's okay. Yeah,
Sorry.
because the chips will be different.
Sorry, okay.
That's good because I'm not sure.
Good, that's
Question? Someone have a question?
How did you get that transformation?
It's just something you can do. If you just say take the natural log of this function, that's what it looks like. So it's like one of those like take a class in calculus and that's what happens, right? So this is the math background that you're supposed to have in prereq, right?
The natural log of the previous term, or which one?
If I take the natural log of this thing here,
Of that. Okay.
yeah, just this utility function.
Okay.
Okay, so this utility function will become this utility function. Then I can add my other part of the Lagrangian. Blah, 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 right?
So then what's that second term?
This is the derivative of this.
Okay.
Let's do it this way. 1, 2, 3, 4, right? So the derivative of 1 prime gets you to 2. And that's a mess. Okay? The derivative of 3 gets you 4, and that's cool.
And then the natural log of 1 gets you 3.
That's right. Yeah, perfect. So we want to use 1. We want to use 3. We don't want to use 1. Yeah.
So going back to 1 to 2, basically you took it in respect to B, the beer.
This is with respect to, this is Lagrangian with respect to beer. Yeah. Yeah.
Why don't you take the natural log of the rest of the term also? Why
Uh,
do you leave that part out?
this has been transformed into this, and that is, but not this part here.
Yeah, why do you?
Because this is just the, I'm just talking about the utility function before I put it in the Lagrangian structure. Okay? So you transform it first, then you can put it with this part here. This is not changed. This is okay. Okay? Other question?
On the handout, you said that the lambda can sometimes be positive.
There's a positive coefficient in front of the lambda, yeah. So you could say plus or minus lambda when you set it up.
Okay.
Doesn't matter, just be consistent. Yeah, I'm using a negative just because. Okay? Yeah.
So 4 would be the derivative in respect to beer.
4 is the derivative with respect to this equation 3.
Oh, the whole thing.
Yeah, because I'm taking it with respect to b. Right? So this doesn't even
Oh, yeah,
happen.
yeah,
This
that's
doesn't even
right.
happen. Right? It drops away. Yeah? It'll be fun. You'll have a great time with this homework. Any other questions on this thing right now? I'm going to flip through my notes and make sure I haven't missed anything.
What is edgeworth for?
Edgeworth. Oh yeah, let's do an Edgeworth box.
A box.
Doing the box. Okay, I'm going to do 2 things quickly. We have 5 minutes, so hold on. Okay, so it's a transformation of the function. It's not. So it's like basically.
So we can say that we treat it the same way.
So look, here's your utility of beer plus chips, right? And then you say 2 times that. This is your utility is still growing. It's still growing, but the utility is not the same number. It's still growing. So this is a transformation. This is a monotonic transformation of this. So the idea is that you're not changing the way that you think of beer and chips. You're just doubling everything, right? So it's like what's called the money illusion. If you just double the amount of money in the economy, prices will double, income will double, you're just as happy, right? That's a kind of monotonic transformation. So let's look at the Edgeworth box for a second. It's a concept that's kind of handy, and it comes up when there is no. It's a way of thinking about prices or bartering when there is no money. So over here on the bottom, I'm going to call this chips, and I'm going to call this beer. Now we know that if I'm over here and I have indifference curves like this, right? I can just keep going. And then if this is my origin here, O1, right? But say that someone else has O2. And for me, this is more beer, and this is more chips, right? At O2, this is 0, 0. Flip it over upside down, right? It's upside down, or it's flipped over. This is 0, 0, so this is more beer. 0 beer, more beer. Does that make sense? Okay, what is this person's indifference curve going to look like? They're going to look like this. Okay, I'm just flipping it over. I'm combining essentially 2 sets of indifference curves in one box. Everybody seeing that? Okay, now here's the key. Let's call this U Mr. A, and then U Mr. B. Or, yeah. Mr. B, there's a trade-off. Whenever you see 2 curves touching in economics, pay attention, right? 2 curves crossing, 2 curves touching. That's when you should pay attention. This here is a place where these 2 have the same substitution between the 2 goods. That's the key. They have the same, I hesitate to say marginal rate of substitution between 2 goods, but I think they do, okay? So they have the same marginal rate of substitution between 2 goods. In a sense, if you're going to have an exchange, they would actually be able to set a price between each other, an exchange price that actually runs right down the middle here. Now, before the time I drew a straight line. I said this is a budget constraint, because that was the trade-off between one good and the other subject to your budget. This line here just represents an exchange between the 2 goods. Forget the budget constraint, right? Because there's no money here. So the idea is that if these 2 are going to trade, they'll trade at this point here. If we draw an Edgeworth box here, and we say, there's one person, there's the other person, then they're not trading, right? They have a lot of space. This will end up mattering for trade. They have all this area here that is open for moving together, open for exchange. And they will move towards each other until they stop here. And the reason they'll move towards each other is because the sum total of chips in this world is represented by the length of this line, right? So this is, and I'm bringing up a really big concept, and I'm just mentioning it. But this is like a Robinson Crusoe world where there is no money, but you just have beer and chips, and someone's got beer and someone's got chips, and they're trading off with each other.
So each one, the one on O2 story is trying to get diagonal.
They're trying to go away from their origin.
So everybody's trying to get to the best
middle.
point for them is the middle. Okay.
Yeah. Okay, let's call it quits. I'll see you guys on Thursday. Office hours today, 4 o'clock. Thursday office hours are also wrong. They're changed to whatever number. It's on me.